Bismillahirrahmanirrahim. Welcome to the second part of the 12th lecture of Statistics and Probability Theory. We will continue with the topic Hypergeometric Distribution. Example 1. What is the probability that a waitress will refuse to serve alcoholic beverages to only 2 minors if she randomly checks the IDs of 5 among 9 students, 4 of whom are minors? So, as the particular scenario is given here, that there is a waitress who is serving the alcoholic beverages. There are 9 students among 5 to whom she randomly checks the IDs, and she will refuse to give the alcoholic beverages to the one who is minor. First, we will see either the properties of the hypergeometric distribution is fulfilling the scenario or not. The very first property is, for each trial, there are only 2 possible outcomes, success and failure. So there are 9 students and each student is a trial. So if she check the ID and she find out that the student is minor, so it will count as success, as we are interested to find out the probability that waitress will refuse to serve the beverage to the minor. Otherwise, it is failure. If the student is not minor, so she will serve the beverage. It means it is the failure, because we are interested in not serving the alcoholic beverages to the minor. So if she refuses and find out that the student is minor, this one is success, otherwise it is failure. The very first property of the hypergeometric distribution is fulfilling here. The second property is the number of trials n are fixed. As she have 9 students and she is checking out the 5 IDs, so that the number of trials are fixed. The successive trials are dependent, that is, the outcome of each trial is affected by the outcome of the other trial, that is without replacement. This case is for sure this is the case of without replacement sampling, because once she have checked the ID of the student and she find out that he or she is a minor, so she will just refuse to serve the beverage and go to the next student. That particular student will not again come to the sample. That is, she will not check the ID of that particular student. That student is excluded from the sample now. So this is surely the without replacement case, as we are not putting back the student in the sample space again. The outcome of each trial is dependent. The last property is the probability of success changes from the trial to trial. As it is the without replacement case, so we already know that in the case of without replacement, probability of success will surely change. It will not remain constant. X represents the number of minors, as our success is that we find out that the student is minor, so X will be associated with this P. Capital N represents the total number of students. Small k represents the total number of minors, because k is basically the number of successes in the population, and we have total 9 students in the population, and our success will be the minors, so there are 4 minors in the population. And small n represents the selected IDs of the students for checking. So we can apply the hypergeometric distribution here, as its PDF probability mass function is P of x is equal to kcx n minus x, p small n minus x, divided by NCN, where x is equal to from maximum of 0 n plus k minus capital N to minimum of k and n. So as we know, there are 4 minors in the population of 9 students. So K will be equal to 4. Capital N is 9 as there are 9 students. Small n, K is 4. Small n is 5 as she will going to check the IDs of 5 students. X is equal to from maximum of 0, 4 plus 5 minus 9. This 4 is K, 5 is small n, and 9 is capital N, as you can see from here. To minimum of 4 and 5, as it is minimum of K and N. K is 4 and N is 5. So it will surely start from 0 and it will go to the minimum of this 4 or 5. Minimum value is 4. This is 4 plus 5 minus 9. This is 0. And 9 minus 9 will be 0. So this will surely be 0 and it will go to the. On solving this, we will find out that this one is 0 and 4 plus 5 minus 9 will also equal to 0. So this is 0. So the starting point is 0 and it will go to minimum of 4 or 5. So minimum value is 4. So it will be equal to 0, 1, 2, 3 and 4. So this is the range of the random variable x. If x is equal to 0, so there is not any minor in the selected sample. If x is equal to 1, there is 1 minor out of 5. If we substitute x is equal to 2, x is equal to 2 here, it will give us the probability that there are 2 minors out of 5. So, as you can see from the statement that what is the probability that waitress will refuse to serve alcoholic beverages to only 2 minors? So, you have to find out the probability that x is equal to 2, which is equal to 4C2. On solving this, you will get 0.4762. So, this is the probability that waitress will refuse to serve the alcoholic beverages to only 2 minors. Example number 2. A particular part that is used as an injection device is sold in lots of 10. The producer deems a lot acceptable if no more than one defective is in the lot. If there are 2 defective parts in a lot, a sampling plan involves random sampling and testing 3 of the parts out of 10. Find the probability that lot is accepted. So there are the lots in which we have 10 parts of the injection devices, and the producer says that if he found more than one defective in the lot, he will not accept the lot. So the minimum tolerance level is 1 defective. If the parts in the lot of 10 are more than 1 defective, so the lot will not acceptable. He will accept the lot only in the case if there is no defective in the lot or there is only 1 defective in the lot. So as you can see here, there are 2 defective parts in a lot. So he is going to test 3 parts out of 10. Find the probability that the lot is accepted. So first we will see whether the properties of hypergeometric distribution are fulfilling this scenario or not. The very first is for each trial there are only 2 possible outcomes, success and failure. So we have to accept the lot. For this, parts should be non-defective. So whenever the part is non-defective, it would be success, and whenever they are defective, it would be failure. The number of trials are fixed there are 10 parts in a lot in which you are selecting 5 parts for the inspection. So n is equal to 5. The successive trials are dependent. That is, the outcome of each trial is affected by the outcome of other trials. This is without replacement sampling. Surely, if one part is tested or inspected, it should not be again. We will not substitute that part again in the lot. It would be kept aside. So we will go to the other part. So this is the sampling without replacement. And as you know, in without replacement sampling, the probability of success changes from trial to trial. Here X represents number of defective parts in a lot. Capital N represents the total number of parts in a lot. K represents the total number of defective parts in a lot. As we are interested in the number of defective parts so that we will accept or reject the lot. So we are associating X to the number of defective parts. So automatically K is the number of total number of defective parts in a lot. So by applying the probability mass function of hypergeometric distribution, which is P of x is equal to this, as x is equal to maximum of 0, n plus k minus n to minimum of k and n. So this would be equal to, as n is 3, as they are testing only 3 parts, k is equal to 2, as there are only 2 defectives in the lot, and capital N is equal to 10. And minimum of k and n, k is 2 and n is 3. So this is 3 plus 2 minus 10. This is negative value and this is 0. So for sure 0 is maximum. We will start from 0 and minimum is 2. So it will be 0, 1 and 2. So the probability that the sampling plan finds the lot acceptable, as the producer is saying he will not tolerate the defective parts more than 1. So what are the scenarios in which the lot is accepted? The very first scenario is if there is no defective item in the sample of testing parts. So as x is related with the number of defective parts, so if we put here x equal to 2, it means there are no defective parts in that particularly 3 selected parts for the inspection. So this is the probability that there are no defective parts. Plus, or you can say that producer says that he can tolerate one defective part in the lot and he can accept the lot. So we will substitute x is equal to 1. This is also the second case in which the lot can be accepted. So either this could happen or this could happen. The lot will be accepted. We will consider the probabilities of both cases and add them, which will give us the total probability that lot is acceptable, which is 0.933. Lot of 4 components each are deemed unacceptable if they contain 3 or more defectives. So as they are saying there are 40 components in a lot and lot will unacceptable. Here the word unacceptable is used here if it contains 3 or more than 3 defectives. The producer for sampling a lot is to select 5 components at random and to reject the lot if a defective is found. So he is saying that there are 5 components at random that they are selecting for inspection, and to reject a lot if the defective is found. What is the probability that exactly one defective is found in the sample if there are 3 defectives are in the entire lot? So they are saying that there are total 3 defectives in the lot. Total we have 40 components and we are inspecting 5 components. This is the case of acceptance sampling. Example 2 and example 3 are basically the case of acceptance sampling, that we will accept or reject a particular lot So here is the solution. As you know from the previous example, this is the case of hypergeometric distribution. So small n is equal to 5, capital N is equal to 40, k is equal to 3, as there are exactly 3 defectives in a lot, and they are saying that find out the probability that there are exactly 1 defective in the lot. So on substituting the values in the probability mass function of the hypergeometric distribution, which is k cx capital N minus k and small n minus x divided by n c n. You can find out the limit of the random variable x as well by using this from maximum of 0 n plus k minus n to minimum of k and n. So this will give us the probability 0.3011, which is the probability that there will be exactly 1 defective in the lot of 40 components.